Hi everybody, welcome to the fifth video on indices, National 5, and in this video we're going to be looking at bringing all the rules together and trying to solve one that involves all the rules. So the multiplying and dividing rules, the power rule, a zero rule might pop in, any negatives, and of course the beetroot rule or the root rule. So our first example is just straight out one like this. So we have x to the 4 into x to the 3 plus x to the 7. Now the best way that I can tell you to try and solve these is to work from the inside outwards. So that would involve following your rules of BOD mass as well. So you have your brackets, any powers, dividing, multiplying, adding and subtracting. So in this case, we'll deal with what's in the brackets first. Now, because these are two different powers, these are two different indices, we can't add them together. If they were both x to the 3, we could add them together, but unfortunately, since one is a 3 and one is a 7, we can't do that. So we're going to have to look at our powers. There's no powers here. Any dividing going on? Nope. Now our multiplying. Yes, there's some multiplying. So we've got this x to the 4 times x to the 3, and when you multiply two indices at the same base, you simply add their powers. And we've also got x to the 4 times x to the 7, and once again we just add them together. So 4 add 7, so x to the 4 plus 3 gives us x to the 7. Add x to the 4 add 7 gives us x to the 11. So that was just straight out multiplying them out. In this example, we've got both. Now, because we've got something as a fraction here, the best thing I can suggest to you is to tidy up the top, tidy up the bottom, and then deal with it. So in this example, I've just got a straight out multiplying on the top. So x to the 2 times x to the 3 is just x to add 3 over x to the 7. So that's going to break down to x to the 5 over x to the 7. Now, because this is a dividing, it's going to be x to the 5 subtract 7, which gives us x to the negative 2, because 5 take away 7 leaves us with negative 2. And we generally want to leave these as a positive index. So because this is negative, the way that we're going to make it positive is we're going to bring it down underneath, and we get 1 over x squared. Now over here, looking at this big bad complicated thing, we still follow our rules, work from the center out the way. So following for what I did here, I'm going to tidy up the top first. So we get y to the 4 times 2y to the negative 3. Well, that's going to be 2y to the 4 take away 3. On the bottom, we've got 4y to the 2 times y to the 3. So that's going to be 4y to the 2 add 3. And that's all to the power of 3. Now tidying up, we're going to be getting 2y to the 1 over 4y to the 5, all to the power of 3. So once we've done that, now we can deal with this fractional thing. So this fractional thing, we're going to have 2 divided by 4, which is, well, a half. And then we've got y to the 1, and we're going to take away the 5 there, and that's still all to the power of 3. So we get 1 over 2y to the 4, because when I do 1 take away 5, it's going to give me negative 4 on the top. So we bring it down to the bottom for 2y to the positive 4, still all to the power of 3. And then we do the power rule. So 1 to the power of 3 just gives us 1. 2 to the power of 3 is 2 times 2 times 2, which gives us 8. And y to the power of 4 is y to the 4 times 3. And that gives us 1 over 8y to the 12. Now, that seems like a lot of steps, and it really is, but taking it one wee bit at a time, just tidying up one wee bit, breaking it down slowly and slowly, and you finally get to it. Now, the last example I have here is this big monstrosity here. So, once again, dealing with any brackets first of all. So, inside we've got all this for the first one. So, we've got 2 times by 4. Nearly forgot that 4 there. 2 times by 4 there. There's just a 1 there, so there's no point in putting 2 times 4 times 1 because it will give me the same answer. Times by, now we've got an x, and we're going to be doing 3, add -1, add 2, and that's all to the power of 3. And we've got a wee bit on the end here like so. So we're just tidying all this bit up in here in the brackets. So we've got 8 x, now 3 add -1 is going to be 2 because an add negative becomes a negative. So 3 take away 1 is 2. Add another 2 is going to give us a 4. That's all still to the power of 3. And we've got 5x to the 3 here, all to the power of 4. Then we're going to be using our power rule to break this out. So we've got 8 to the power of 3 for this bit, then x to the 4 times 3. So 8 to the 3 is just 8 times 8 times 8, which gives you 512. And x to the 4 times 3 is 12. Over in this case, we've got 5 to the power of 4, x to the power of 3 times 4. So 5 to the power of 4 is 625. X and 3 times 4 is 12. We're on the home stretch now. So now that we're multiplying these two together, we can do 512 times 625. Before you say it, I'm using the calculator. Times by x to the 12, add 12 because these two are going to be adding together. So 512 times 625 is 320,000. X to the 24. Now, it's not going to be this complicated in any examples that you might see in the future. Then again, it might. But the rule to remember here, or the process to remember, is to start from the center and work your way out. So going back to this example, this would probably be one of the best to explain that. I tidy up the top and the bottom first of all to get this. And then I do any division, so I'm staying within the brackets until I get down to something simple that I can use to this power. So work from the center outwards, take your time, and follow your rules of BODMAS.